At this point, we're going to start to take a deeper look into one of Rust's most important features, which is ownership. So a lot of people say that ownership is Rust's most unique feature and has deep implications for the rest of the language. So it enables Rust to make memory safety guarantees without needing a garbage collector, which is very common in other languages. And it's very important to understand the concept of ownership. So ownership is a set of rules that govern how a Rust program manages memory. So all programs have to manage the way they use a computer's memory while running. There are a lot of languages that they use garbage collection that regularly looks for no longer used memory as the program runs. And in other languages, the programmer must explicitly allocate and free the memory. But Rust has a different approach where memory is managed through a system of ownership with a set of rules that the compiler checks. If any of the rules are violated, the program won't compile. So this guarantees some safety while you're programming. Rust will try not to allow you to violate certain rules. And none of the features of ownership will slow down your program while it's running. We already talked about stack and the heap, which is fundamental to understand ownership. And now we'll start taking a look into ownership on its own. So there are certain ownership rules. So each value in Rust has an owner. There can only be one owner at a time, and when the owner goes out of scope, the value will be dropped. To understand better ownership rules, we will have to take a look in variable scope. This will be a topic of future tutorials. So, as we mentioned before, each value in Rust has a variable that is called owner of the value. Every stored data in Rust will have an owner associated with it. So if you, for example, define let age be equals to 30, age is the owner of the value 30. Each data can have only one owner at a time, and two variables cannot point to the same memory location. The variables will always be pointing to different memory locations. We can transfer ownership. We will talk about that. We can transfer ownership, for example, assigning a value of one variable to another variable. We can pass a value to a function, and the ownership of a value also changes when we pass an object in the heap to a closure or function. We can return a value from a function, and ownership passed to the function will be invalidated as the function execution completes. And we'll talk about all of that in future tutorials, starting with more easier concept to understand, which is the variable scope. So I'll see you in the next tutorial.